All right, we're going to do the second part of lesson 10.2 on measuring angles and arcs. The previous part of this lesson, we focused on how to find central angles, what they were, identifying the parts that how they relate, I should say, to arcs and so forth. Today, we're going to get more into finding arc length. Arc length is the measure of that arc of the circle, that piece of the circle, and it's just a part of the circumference is what it boils down to. We're also going to look here first at finding arc measures, which is a degree measure, or an arc measure without having a central angle. And we'll look at how we get questions like that. And what we look at here is a circle graph here, and it says a circle graph shows how teenagers spend their time online. We're supposed to find the indicated arc measures. All right. So an arc measure, let me just reiterate this. An arc measure is a degree that is correlates to its central angle. So, the social media is this arc AB. It's a minor arc AB, and it relates to central angle APB. Okay, the video section here is represented by arc CB, and it relates to the central angle BPC, and so forth as I work around here. So these are the sections or the pie pieces of the circle graph. These are the arcs associated with it, and what they're asking us to do is tell them what is the measure of each of these arcs. So what is the measure of arc AB? Well, we're not given a central angle here. But what we do know is that because this circle graph is complete, there's no gaps, then the distance all the way around here is equal to 360. Okay, so I know that if I add up these central angles in here that represent these different pie pieces, if I add them up, they got to equal to 360. All right, so what we'll do now is rather than having a central angle to compare to, what we now know is that the social media, which is 44%, that means that the social media represents 44% of 360 degrees that are in here. So I'm simply going to find a percent of 360. So how do I find 44% of 360? Well, we change the percent to a decimal by moving the decimal point two places to the left. So that's 44 becomes 0.44, and then multiply by 360. And the central angle now for angle APB has got to be 158.4 degrees, because the arc, I should say that this part of the circle graph takes up 158.4 degrees of the entire circle. So the central angle is 158.4 and arc AB is 158.4. We continue doing that for the rest of them. So videos represents 20%. That means that's 20% of 360. So 20% of 360 is 0.20 times 360. That's 72. So that means angle CPB has to be 72 degrees and arc CB is 72. Okay, music is 14%. So that's 14% of 360 degrees. 0.14 times 360 is 50.4. So that central angle is 50.4, which means the arc is 50.4. For the search engines is 12% of our circle graph. So percent to a decimal, move it to two places to the left, 0.12 times 360. That answer is 43.2. So that tells us that the central angle DPE has got to be 43.22 degrees, which means arc DE is the same as the central angle. That arc is 43.2 degrees. Games represents 7%. Careful here when you move the decimal two to the left, make sure you go two to the left. One gets you past the 7. A second movement, we got to add a 0. So this is going to be 0.07 times 360, which gives us 25.2 degrees. So this central angle EPF is 25.2 degrees. Arc EF is 25.2 degrees. And the last is other. So that's 0.03 times 360, which is 10.8. So that means this angle FPA needs to be 10.8 degrees, which makes arc FA 10.8 degrees. So we were able to calculate arc measures and central angles using the percentage out of 360. And if we add all these up, it does come out to 360. Now, depending on your percentages, these may get rounded. You may be off by a couple of tenths here when you go to add up if they don't come out nice and even. But we understand that through that rounding is where your error was. So this is how we can find arc measure out of a circle graph without actually knowing the central angle to start with. We can actually find the central angle using the percent that pie piece represents. Okay, another way of doing this same question, and these are how you're going to kind of see it tonight. This says, as part of a survey, 1,600 people were asked to name their favorite sport to watch. The table below summarizes their answers. The information is also represented in a circle graph. So here are the number of people that chose. I think they mistakenly put these two in the wrong order. I think football should be bigger, but that's just a personal opinion. So football is 432, soccer 528, baseball 128, basketball 240, hockey 96, other 176. If you were to add up these numbers right here, it's going to add up to 1,600 because these are all the people that were surveyed. Okay, they're telling us we need to find the central angle for soccer. All right, for the soccer slice of this circle graph. And they say don't round. All right, well, 528 out of the 1,600 people say they watch soccer as their favorite sport. So let's convert that ratio to a percent. So that's 528 out of 1,600. If you do the division, you get 0.33. Now we got to convert 0.33 to a percent by going 2 to the right, so 33%. So 33% of the people say they watch soccer. So that means, this is kind of going back to our last example, that means that this percent right here is 33% out of the entire circle. So now we can find that central angle by finding 33% of 360. So 0.33 times 360 is 118.8. So therefore, the central angle for soccer should be 118.8 degrees. That makes this arc 118.8 degrees. Okay, so added a little bit to it in that we had to generate our percent first and then apply our percent to 360 in this type of situation. Okay, so that's a little bit about finding arc measures in circle graphs. The next thing I want to touch on is arc length. Okay, arc length, like I said, arc length, arc measure are two different things. Okay, what arc length is, it's the distance between the endpoints of an arc that's measured along the arc in units. All right, and because the arc is a part of the circle, its length is a fraction of the circumference. So arc length is a percentage or a part of the full distance around the circle or circumference. All right, so to calculate arc length, all right, we're going to use two different, you're going to be given two different formulas. I'm always going to use the equation version, and I'll show you why in a second. But to find arc length, we need to understand that the length of the arc we're looking at, the ratio, I should say, of the length of the arc to the circumference is going to be equal to the degree measure of that arc to 360. So think about percentages, if you will. This would be part over whole, the part of the circle we're looking at over the, the part of the circumference of the arc to the total circumference of the circle. This is part, the degree measure of the arc to whole, which is the distance all the way around the circle. All right, so as a proportion, we can find arc length using this. So it's, again, it's taking this directly out of the definition here. So L is my arc length. So it's the ratio of the arc length to circumference, circumference being 2 pi r. That's how we find circumference of a circle. So L over 2 pi r is going to equal X. Now that X is the degree measure of the arc over 360. So this is what we generate here to find arc length. And you can see there's two unknowns. Well, three unknowns. Arc length, the degree measure, the central angle part of it, and then the radius. So there's three unknowns in this formula, if you will. So we got to have at least two of those. All right. So generally right now we're going to be given a central angle and a radius and find arc length. Now this is a proportion, which is fine. But if you simplify this proportion, you get an equation that I think is a lot easier to work with. So what I've done really, if you look at the proportion, is I've multiplied each side by 2 pi r. If you multiply each side by 2 pi r, we'll cancel the denominator over here with the 2 pi r we multiplied by, and we'll multiply x over 360 by 2 pi r. So what this does is it isolates arc length, which is what we're trying to solve for. So if we're given the central angle and the radius, I can plug it right in here and get to my arc length. Okay, so again, this is what I'm going to use. And just to talk a little bit more about it, so this is the central angle over 360. So that's the percent. If you think about it, the central angle over 360 is a percent of the circle that you want to find the arc length of, and this is the arc length or the entire circle. So it's percent of the circle times the actual circumference all the way around. Okay, let's take a look at some of these. So it says up here the circle below has a center at O and its radius is 4. So A to O is 4, B to O is 4. Given that the measure of angle AOB is 30 degrees, find the length of the minor arc AB. So what they're asking us to do is to find the distance if you were to walk along this curve from A to B. Okay, it's not a straight line, it's part of the circle, so it's an arc. All right, so I got to find the distance from A to B. Note up here too, they're saying give your answer in terms of pi and include the correct unit in your answer. So this is something a little different. It's not hard to do. I just want to show you this process though. All right, so since we're finding the arc length of AB, I'm going to apply my arc length formula. Arc length is equal to central angle over 360 times 2 pi r, 2 pi r being the circumference. Okay, so plug in what you got. Central angle is 30. That goes in place of x. The radius they tell us up here is 4. That goes in place of r. Now, if I'm just doing this and getting a rounded answer, all right, then I would get a calculator out and I would multiply this together, divide by 360, get my answer. However, this is kind of how I would do it in a calculator, I should say. I do 30 times 2 times pi times 4, hit equals, divide that all by 360, and I'd get my answer. That's not how they're asking you to do it, though. They're saying leave it in terms of pi, which essentially means we need to take this fraction, these two fractions that are being multiplied together. Notice all I did was took 2 pi over 4 and put it over 1. So I'm multiplying these two fractions together. I'm just going to do some cross canceling. I'm going to reduce this as much as I can, and then I'm going to have my answer in lowest terms in terms of pi. I'm going to leave pi in there. So the first thing I'm going to do here is I'm going to divide both this 30 and 360 by 30, and that'll give me 1 over 12. I'm going to continue to reduce. This 4 and this 12 can both be divided by a 4. That'll give me a 1 and a 3. So I do all my canceling here, and then I multiply. When I'm done, I can't do any more canceling. I multiply the numerators to get my new numerator, denominators to get my new denominator. So up top, I got 1 times 2 times pi times 1. That's just 2 pi. On the bottom is 3 times 1. So this, after I cancel and multiply numerators, denominators together, I just get 2 pi over 3. So in terms of pi, this arc length right here, the distance from A to B along this curve, remember this is a curve, it's part of a circle, is 2 pi over 3. So this is the answer they want. Okay, just to give you an idea of what that is, if I took 2 times pi and divided it by 3, I get about 2.1. So if we did round to the nearest tenth, that would be my answer. Okay, so that's how we find arc length. Let's do another. In the circle below, which has center V, the radius is 9, so that means V to X is 9, V to W is 9, V to Y would be 9. Given that WVX, this angle is 160, find the length of major arc WYX. Give the exact answer in terms of pi, include units. Okay, so first things first, we're not trying to find this arc, this WX piece. We're trying to find the other part. Okay, so the central angle for this major arc WYX is going to be 360 minus 160, right? 160 is this part. I want the other part. Together, these two got to add up to 360. So that's going to give me 200. So the central angle I'm going to use for arc WYX is going to be 200. All right, that's going to be my X in my formula. So again, here's my formula. Length equals x over 360 times 2 pi r. X is the central angle, r is the radius. We have the radius given here. I just found out my central angle, so plug it in. Okay, my next step, because we're going to simplify it in terms of pi, is I want to know what my numerators, denominators are. So here are my numerators. It's going to be 200 over 360 times 2 pi times 9 over 1. And I want to start canceling things. Okay, start here. The 200 and 360 can both be divided by a 40. That'll give us 5 over 9. And now notice I got a 9 in the numerator here and a 9 in the denominator, so I can cancel those to get 1s. And then multiply what remains. 5 times 2 pi is my numerator. 1 times 1 is 1. It's my denominator, so I don't need a denominator anymore. The answer here is 10 pi. Okay, so that's the answer they want. 10 pi centimeters is if you were to travel from W, walking along the curve, through Y on my way to X, you travel 10 pi units. Now, if I want to know what the number is, it's about 31.4 centimeters. Okay, it's about 31.4 centimeters from W through Y to X walking along that curve. All right, so that's finding arc length. You're going to have both these styles of questions tonight. All right, tonight's work will cover examples of both the circle graphs, finding arc measures, and then finding arc lengths, which is using the formula and generating the answers. Okay, there's not too many awful homework questions, too awful many, I should say. So I'll let you guys get at it.